to our next one. Alright, so with that in mind, let's move on to our next process. You all probably know it as this right here. But what is the actual technical process term? And what's it mean though? Yeah. Well, tell me, let's back up for a second. Now, which process is this most similar to? GMAW or SMAW? Stick, right? And why is it similar to it? Because you use a stick, right? You're still using that handheld manual system, right? But there is one significant difference in terms of SMAW technique that TIG is different in. What is a significant or process hand difference?
The feeding of the rod?
Yeah, but that's not what I'm going for. Well, that's sort of related, the feeding of the rod, but not. How is the rod? Where is the rod held?
In the other hand.
In the other hand. Do you actually hold on to the rod in SMAW?
No.
That would be a bad choice, right?
Yeah.
So in TIG, let's see if we can't find us a nice little.
Like acetylene welding.
It would be very similar to acetylene welding, absolutely. We just called it in the SMAW because it's closer to SMAW than it is into GMAW, since we're talking welding processes. Although acetylene welding is true, absolutely. So you've got two systems right here. You've got the one hand holding a component and one hand holding another component. Now, what industries really like TIG? The houseboat industry is one of them, yeah.
Real small.
Okay, you can do precision type work, close up. What would you say is harder, stick welding or TIG welding? And why is it harder? So precise, and you basically have to use both hands at the same time, right?
You have to do two things.
Yeah. And you have to work real hard. I don't know if you played the games of it, but this is actually very challenging on the online simulators. So good process, a little bit more challenging than stick welding. It is similar to acetylene welding, and of course, technically we're dealing with something that is really more melting the material than anything else. So you all probably deal with it more than I do in terms of the actual physical thing, so it's not a big deal there. But anything that jumps out to you about TIG that you think is interesting? Do you get paid more for TIG than you do stick? Potentially. Absolutely. Higher skill, better results, and could you possibly get into different fields of actual applications? Could you get into electronics or precision equipment? Absolutely. So skill level matters a whole lot in this process. All right, so that's good for a little intro. Let's take a break. Next question, why tungsten at all? So what's the advantage of why do we do tungsten gas? Well,
Maybe like you can, it's maybe not as messy.
well, why would somebody spend the time in making equipment that looks kind of like that with all this system just for switching out the tip, so to speak?
Too much time for like non-ferrous aluminum.
Well, let me give you a hint, or let's point you in the right direction. Looking at the screen right there, what is abnormal about the setup? Not the handle or the welding itself, but look at the equipment. What's different than everything else?
You got a pedal.
You got a what?
Pedal.
You got a cooler on it, right? You got to keep the thing cold or cooler. Why did suddenly we have a water cooler or some type of coolant system attached to the unit now? Why do we attach cooler systems anyway?
Heat control?
Heat control. You can go hotter with this stuff. And that gives you some advantage. So therefore our head tips are actually a different material. Now, a water cooler is a common one that actually, and you notice it. Where's the water cooler circulating? Just the head, right? Just the torch component. We have to keep it cool, or otherwise we're going to melt down, right? Now, you also notice that TIGs typically can come with a, what kind of pedal?
Foot pedal.
Foot pedal. Why are we suddenly interested in having a foot pedal?
Control people.
Yeah, we always have to control. We're not running this thing full blast all the time. We have more precision, more control. Get in position, you hit the foot pad, it kicks on. Now, that's one of the key things you want to remember about the process. And, let's see here. And there is one very unique type of issue with tungsten gas. And it all revolves around this. What is that?
The current, direction of the current?
Direction of electron flow. Tungsten, or TIG, has options for change, right? We can flow the current one direction and get one result. We can flow the current another direction and get another result. Okay? First off, any questions on what current flow is? Because this is kind of crucial to understand the process. When I hook up a normal SMAW and I ground this thing right here, there's my clamp, this plate, and I throw the stick to it, what is the direction of electron flow?
It depends on if you're on positive. It could be positive.
What is the most common direction?
Electrophotic.
Yeah, what's the most common flow? Where's the negative and where's the most common positive?
Well,
You got A and B. A is positive, B is negative. So, and we know that the electrons flow from positive to negative. That's how all our direct current stuff works. We are flowing one way or the other. Now, by the way, I switch over to AC. If I have a system that runs AC, what actually happens? It goes back and forth. How many times a second? 60. In the U.S. it's 60. In other countries it actually is, I think, 50 in some cases. Well, in this particular case, you know, for the most, we can go AC, but just to get the point across, to get started, we're talking about plus or minus and direct flow. So we know electrons are over here and want to get over here, right? And in TIG, if we change the direction of flow, we get different results. The type of different results and everything, that's important for you to kind of be aware of because it affects the process and it's your choice of selection in what you want to do. So always keep in mind that also matters. So you notice the TIG has more equipment, potentially. It has the water cooling component to keep things under control, and sometimes can actually be done without filler. You can actually do it without filler in terms of what you're making. But we do know that its work is very worthwhile for a lot of industries. Aluminum, obviously, it's great. Aerospace, electronics, good stuff with it. So, any questions about TIG you want to ask?
Is it like more? Explain.
Take a moment.
Like it's when you TIG weld, is it more stronger than anything?
Okay, so like, how does it hold up in terms of strength? Well, the good news, or the answer to that question is this. When you weld something, it is all about, let's say that we run some kind of V-groove weld right through here. Now, keep in mind the type of weld you do, whether it be TIG, SMAL, whatever the case may be, has nothing to do with the actual weld symbol itself. What I should say is, like, the butt joint is still the butt joint, a fillet weld is still a fillet weld, V-groove still a V-groove, no matter what. So part of the strength is in the shape of the weld, which is irrelevant of whether you're doing TIG or whatever. Part of it is in the filler material that you're putting in. So there is a difference significantly between TIG and, let's say, you know, an SMAL, what is it, 6011, rod, you're getting different types of material. So there is a strength difference right off the bat. But penetration controls shape, right? The more you penetrate, the more shape you get. The more filler material you have in there, the more strength you get. So the answer is actually not one or the other. It's just a different process that can give you a different shape and put in a different filler material potentially. So if that answers. So the answer is actually sort of yes or no. But it still boils down to shape and filler and penetrate. Well, shape is penetration and the filler material going in. And of course, obviously, if your process doesn't melt the existing metal to get in there to it, that would be a weak reduction. So it's not a very good answer, but it's actually the facts of how the welding process works. So it's really, TIG is actually better for the precision and obviously the temperature operations. Other questions? The good news is when someone actually specs out a TIG weld, they're either interested in the type of material you're using to weld, or they've already pre-designed the joint, so it's going to be strong enough based on what they're designing it for. Other questions? Ask. All right, so good stopping point for that.